Welcome to Matematika. Today we're going to do problems and solutions of 1.6 polynomial functions and end behavior. The first set is asking you to describe the end behavior of its function using the limit notation. Before doing this, we have to write down the summary of what is going to happen with respect to the degree and leading coefficient as our guide when we do describing the end behavior. So I'll start with having a combination of even degree and the leading coefficient as positive. So when it's even and positive, if you try to make a sketch, both will be on the same direction. So if one, the left side rise up, the other also rise up. Okay? For odd, all right, it's odd and then negative. Odd, negative. Even. Sorry. This is even and negative. So what does even and negative does when you look at in the graph? That would be falls to left and falls to right. That means they are of the same direction. This will be just a guide so that you know how to write down the limit notation. And if you have an odd and then it's positive, all right, odd, positive. As I've said, think about always the right side. When it's positive, odd, the rises up. The right rises up and the left falls down. Okay? When it's odd and then negative, that means think about the right side would be this time is the one that falls down and the left is the one that rises up. Okay, this will be our guide. So let's start. The first question is, when you have a g of x equals 4x to the power of 9, negative 2x to the fifth, or minus 2x to the fifth, plus x. Let's look at the leading term. So we have an odd degree and it is a positive leading coefficient. So a combination of odd and positive. That means our figure would look like this. One rise up, the right rise up, and the left falls down. So we can start saying that the limit, this is to the positive x, and this is to the negative x. To the limit when x approaches a negative infinity, the g of x, this is the negative infinity, the g of x is negative. While the limit when x approaches positive infinity right here, our g of x is positive or approaches to positive. All right? Simple, right? Okay. Just have our guide right there. I simplify the guide. For number 2, letter B, p of x is equals to 3x to the 6th power plus 5x cubed minus 2x minus 3. We'll just look at the leading term. Okay, it's even and positive. So even and positive, even. So positive, that means both ends rise up. Okay, so the limit, this is positive infinity and this is the negative infinity. So the limit when x approaches negative infinity, the p of x is positive, or it approached to positive, and the limit, okay, when x approaches positive infinity, the p of x is also a positive, because we are talking about even. Happens one up, one down, it's for an odd. All right. Letter C. F of x is negative 5x to the 7 minus 6x cubed plus 3. So we look at this. The degree is odd. The coefficient is negative. Okay? Odd, negative. That means the right, the right end is negative going down, and the other one is positive going up, right? So as this approaches a positive infinity, as this x approaches a negative infinity. So you could say, this is what I usually do when I was a student before. I just make a sketch so that I don't get lost. As x approaches a negative infinity, the f of x, look at the direction, it goes up, rises up. So this is a positive infinity, and the limit as x approaches a positive infinity, it falls down. So the f of x is negative infinity because of the odd and even. An odd and negative, I mean. Okay? Let's do letter D. G of x is equals to negative 5x to the 8 plus 7x cubed minus 4x plus 2. Okay, the leading term. So the leading term has an odd degree, even degree. Has an even degree and negative leading coefficient. Even, negative. That means if you try to look at that, both falls down. Okay? Falls to the left, falls to the right, as it approaches the positive infinity and negative infinity. So you could say here that the limit as x approaches negative infinity, the g of x is negative infinity. And the limit when x approaches positive infinity, these are both ends are negative infinity. So g of x is negative infinity. Okay, letter E. F of x is x to the 5th power plus 4x squared minus 5. So let's look at the degree. The degree is odd, and leading coefficient is positive. Odd, positive. Positive, when I say positive, the right rises up and the left falls down as x approaches positive infinity and a negative infinity. Okay? So you could say that the limit as x approaches a negative infinity, the f of x is negative. See that it goes down. Right? So the limit as x approaches positive infinity, the function of x is positive infinity because it goes up. Right? So long as you know the degree and leading coefficient and the direction of your end behavior, it will be easy for you to describe. Okay, our leading term is this. So the degree is 2. The degree is even. And it's negative. Even, negative. That means both are falls down. Okay, as x approaches positive infinity and x approaches a negative infinity, the end behavior is negative. That means we could write that the limit as x approaches a negative infinity, the p of x is negative. And also the limit as x approaches positive infinity, the p of x as well is approaches negative infinity, because they are heading towards the same direction. Okay, let's do letter G. The p of x is equals to negative 8 x to the power of 7 plus x to the power of 6 plus 5 x to the power of 4 minus 6. Okay, let's look at the leading coefficient. The degree is the leading coefficient is negative. Okay, add negative. That means the first thing that I have to look is the right falls down, so the left rises up. Right, as x approaches positive infinity as well as negative infinity, then the end behavior is negative infinity and positive infinity. So we could write the x as x approaches a negative infinity, the p of x approaches a positive infinity. Okay. And the other side, the limit as x approaches positive infinity, p of x is negative infinity, because this is odd and even. Okay. For h, f of x is 5x squared plus 6x plus 13. The degree is even. The leading coefficient is positive. Positive even. So when we try to make that sketch, both rises up. Alright, as x approaches positive infinity and negative infinity. So we could say the limit of x as it approached the negative infinity, the f of x approach also to positive infinity. At the same time, when x approaches a positive infinity, the function of x is also a positive infinity. Okay. How about if you are given a graph and then you're asked to write down the limit, describe in terms of using the limit notation. So both rises up. That's the one you're going to look at. That means in positive infinity, the end behavior is positive. As x approaches to negative infinity, the end behavior is positive. Okay? So that means I could write down that the limit as x approaches a negative infinity, let's say the function of x approaches a positive infinity. Same thing as well in the right side. As x approaches a positive infinity, the f of x is also equals to positive infinity or approaches to positive infinity. Okay, let's look at letter J. look at the end behavior. Both are facing down. Okay? That means if this is negative infinity, it's negative. Positive infinity, it's negative. That's it. So the limit as x approaches negative infinity, the function of x is negative infinity. Okay. And the limit as x approaches positive infinity, the function is negative infinity as well. Because if you look at the end behavior, it speaks itself what kind of end behavior you have. All right. For k, if you look at the figure, one up, the left is up, positive, and the right is negative. That means you could say this is really odd and negative. Okay, when you look at the right side, it's negative. Okay, so you could say the limit. This is the as x approaches positive infinity, and as x approaches a negative infinity. So as x approaches a negative infinity, this function is equal to a positive infinity or approach to positive infinity. Look at the arrow. It rises up. While the limit when x approaches a positive infinity right here, the function of x is negative infinity because of this. It falls down. All right. Sketch the graph of a polynomial function. Sketch. That could match the statement. So if you look at the first thing I do when I try to sketch, I will look at the function itself. I will mark this as this approach a positive infinity and approach to a negative infinity. When it's negative, it's negative. That means this might be falls down because it's negative. And this is positive. Okay? Infinity. So maybe I could say it goes that way. That's positive infinity. Okay? That is how the graph looks like as x approaches positive infinity. Now here I look at both ends are negative. Both are negative. So where is the direction of the graph? I could say it's direction that way because it's both negative. Negative infinity as it approaches positive infinity, and then negative infinity as the x approach a negative infinity. That you can do a lot because we don't know the degree. So long as you can do your graph like this, so long as both ends are facing down, because they are both are negative infinity. The limit, okay, one positive and one negative. So if I look at the negative side and the positive side, as x approaches negative infinity, it's positive. Okay, it's positive, the left, as x approaches a negative infinity. Right. While the right, as it approaches the positive infinity, it is negative, so it falls down. Right? That's it. As simple as that. You don't get lost. Okay. The following polynomial function f is given by f of x, a negative 5x to the fourth power plus 6x plus 2. Which of the following statement about the end behavior is true? Okay. So we have to analyze our function by just looking at the leading term. So the degree is 4. Okay, that means the degree is even. And then the leading coefficient is negative. See that there, even and negative. That would be your guide to check if our choices here, for our choices. That means if I try to make a sketch even and negative, so both ends would face down as it approached the positive infinity, as it approached the negative infinity. So we'll start with the number 1. The sign of the leading term is positive. This gives you a no for that, because the leading term is negative. Right there. Negative 5x to the fourth power. The leading term is negative. So from the first line itself, it doesn't say about the end behavior of being true. Okay? The sign of the leading term is negative. Okay, check. And the degree of the leading term of f is odd. Is it correct? The degree is even. So that means that thing odd will make the number 2 wrong. The sign of the leading term of f is positive and the degree is odd. Okay. Positive leading term, wrong. Much more when it says the degree is odd, double wrong. Okay, you don't need to look at the limit notation, because from the statement itself it made the choices as wrong. The sign of the leading term of f is negative. Okay, correct? It's negative. And the degree of the leading term is even. Correct. Okay? Therefore, the limit as x approaches negative, it's negative. Correct. Here from our sketch. And the limit of as x approaches positive, the function is negative. Correct. So therefore, this is the statement that make the end behavior true. Easy, right? By just looking at it, you will know right away. All right. Let me say this. If I can do it, so can you. All right? If I can do it, so can you. Please don't forget to hit the like button, and subscribe if you haven't subscribed yet. See you in my next video.